Okay. Foundations 2.2. Again, a lot of the first part especially is going to be things that should be a lot of review, so you should be okay with it. Slope and the rate of change, we'll talk about equations of lines tomorrow, and then we'll get into scatter plots and things of that nature later in the week. So remember that slope is just the rate of change. Whenever we have the rate of change, you're used to y equals mx plus b. Okay, as far as the equation of a line that you're accustomed to using, where m is going to be, remember whenever it's the rise over run of my line. In terms of using the points and the values, do you remember what the actual equation is? Something you're going to need to remember. So y2 minus y1 over x2 minus x1. Okay, if you're given various points, okay, or 2 points of a line. Or if you're just given two coordinates and say what's the rate of change or what is the slope of your line. Okay. Remember, it goes up and down first, left and right second. Usually whenever I do it, I always have the positive or the negative number on top, because then I can go up or down, and then I always move to the right. Okay. It just seems like it's easier that way. There's a lot less chance of kind of going backwards with my slope. So find the slope of the line passing through the following points. So again, we will go through with our equation. So when we do this, if I have -3, 5, and 2, 1, again, go with my equation. It doesn't matter to me which one you choose as the first point or the second point. Okay, I'm probably just going to go in order and say that that's x1, that's y1, x2, and y2. So, y2, I'm going to do my rise first, so 1 minus 5 over 2 minus a -3. So, the slope of my line, 1 minus 5, -4, 2 minus a -3 is really 2 plus 3, which is 5, so my slope is just -4 over 5. What did we come up with on the second one? 6? 6, 0? 6 over 0? Can you divide by 0? No. So then if it's 6 over 0, then what's my slope? 6 over 0? Do we just leave it like that? You can't divide by 0. What happens if you divide by 0? It's not 0. It's not 1. You want to throw out another number? 47? No? So it has no slope. How come? What did we do? Think about where your point's at. If we would actually have a coordinate, okay, and it looks something like this, and we were at 2, -1, 2, -1, and then 2, 5. What did we just talk about yesterday? It's undefined. Why is it undefined, though? Is it a function? No, why not? Because what doesn't it pass? Vertical line test, right? You have two points stacked on top of each other. Okay? It's a vertical line. Okay? A vertical line is not going to be a function. It's going to be x equals 2 because no matter what, it's going to fall down those points. Now, from there, we have different types of lines with slope. We have a positive slope that rises to the right. Okay, it's like I'm climbing a mountain to the right. I have a negative slope, which is going to fall to the right. Oh, I went horizontal. Did I go horizontal first? It's my fault. Horizontal line is going to be a 0 slope, okay? And then vertical line is going to be an undefined slope. Now, the biggest thing that students interchange that is not correct is that they call a 0 slope and a no slope, they call it the same thing, even though it's different. Okay? Positive slope, I can walk up. Negative slope, I can walk down. Okay? Horizontal slope, I can walk straight across. Okay? Vertical line or undefined slope, okay, it's basically like a vertical wall. Right? Anybody can walk up these. Okay, the first three, or walk on them. Nobody can walk, okay? Nobody's going to be able to walk up the wall. Does that make sense? Okay, you can walk across the floor, you can walk up a hill, you can walk down a hill. Can I be the only one to talk? That would be perfect. Okay, you have then what you should know as Hoy and Vux. Okay, Hoy just stands for, it's just a short acronym standing for horizontal, that's really like an O or a 0 for a 0 slope, and it'll be y equals a number every time. Okay, it'll be an actual constant. Whereas with a Vux line, it's going to be vertical, undefined slope, and it'll always look like x equals a number. So then it says find the slope of the line going through the given points and then tell if it rises, falls, or is vertical or is horizontal. Okay, it's real simple to check to see if it's vertical or horizontal. Okay, so the first thing you want to do to kind of shortcut this, to take two of your answers out of it or automatically get one, is to check to see if your x values match or your y values match. So in this case I have -3, 7, and 4, -5. Do my x values match? No. Okay, so then it can't be vertical. Do my y values match? No, 7 and -5. So now I take out horizontal. If either of those two are the case, then boom, I'm automatically having my value, or having my answer. So then I have to actually use the slope formula. So I'm actually going to have to do y2 minus y1 over x2 minus x1. So again, it doesn't matter to me which one you use. I'm going to go -5 minus 7 over 4 minus -3. So the top side is -12. 4 minus a negative is going to make that a plus 7. So is it positive? Now, if I have two signs that are the same, I need to go ahead and cancel those. So if I have a negative over a negative, remember that's a positive. So I only have one negative, so is it a positive slope or is it a negative slope? I know that it's not a 0 and I know it's not undefined. It's a negative slope. So if it's a negative slope, So if it's negative, should be pretty simple. Does it rise or fall? It falls. Does it fit a special case? Yes, which one does it fit? Horizontal. Why horizontal and why not vertical? Because it's the y values that match, right? So since the y values match, y is equal to -4. So it's going to be horizontal. Now, a little bit of review or something you should know from geometry and Algebra 1 are parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have opposite reciprocals. Okay, so like the example there where you flip the number and then you change the sign. So for it to be perpendicular, you better have one positive and one negative. And it better be reciprocals of each other. Okay, so one's positive, one's negative. If both are positive and both are negative, and it's a reciprocal of each other, it's not it's not perpendicular. Signs have to be opposite, and you have to be able to flip your fraction or your value using its reciprocal. So it says determine whether the following lines are parallel, perpendicular, or neither. So if we find the slope of line 1, does it fit a special case up here with 1? No. So I'm going to have to go -1 minus 3 over 3 minus -3. What's the top side going to be? -4 over 6. How does that reduce? -2 over 3. So then, if it's parallel, what does it have to be? What does my slope of line 2 have to be? The same thing. If it's perpendicular, what does it have to be? 3 over 2, and it has to be positive, right? So if we do the slope of line 2, I'm just going to go 3 minus -3 over 2 minus -2. Change that to a positive, so I have 6 over 4 reduces to 3 over 2. So real simple. First off, are they the same? No. So then if they're not the same, we know we can get rid of parallel. So really it's down to perpendicular or neither. Are they opposite values? One's positive, one's negative. So that's good. Are they reciprocals of each other? Yes. So then they are going to be perpendicular. Steepness of a line. Okay? Regardless if it's positive or negative, you can still have something that's going down, or it's a negative slope that is steeper than something that has a positive slope. Okay? So with steepness, it's all about the absolute value. Okay? Or really just making both of them positive and looking there and figuring out which slope is bigger. Okay? Because no matter what with a slope, depending on which part of the line you were on, or if you're on the top of the hill or the bottom of the hill, did the hill change? Whether you're going up the hill or down the hill? Does the hill change? No. Or the side of the mountain, or however you want to look at it? Okay? The hill doesn't change. It's just a matter of where you're standing is what changes it. If it makes it harder to, like when you go sledding, when it never snows in the winter up here, I feel like. Whenever you walk up the hill is one thing. Whenever you go down the hill on the sled is another. But the hill didn't change. Okay? How you walked it did, but the steepness never changed. So which of these two is going to be steeper? 2/3 or -4/5? Which one is bigger? Forgetting about the positive and the negative side of things. So I don't care about that negative in front. What's 4/5 simplified to? 0.8, right? What's 2/3 simplified to? 0.6 repeating. What's bigger? So what's steeper? The -4/5, right? Again, it does not matter if it's positive or negative, because if it's negative, that means you could be walking down the hill. Okay? If it's positive, you're walking up. Line 2 is going to be steeper because the absolute value of -4/5 is bigger than the absolute value of a positive 2/3. Okay? You forget about the sign because it doesn't matter if you're standing at the top of the hill or the bottom of the hill. The hill didn't change. The steepness didn't change. It just changed where you were walking from. You can still walk down a steep hill or a steep mountain just as well as you can walk up one. Your assignment is on Canvas.